All right, let's get started. Okay, so you're working on PS10, and PS11 will be out tomorrow, and on we go. Any questions or problems? Yes?
I was going to ask, like, so when an exception is thrown, well, not an exception, but it throws a status code.
Yeah.
When that happens, it'll stop the server from running.
Okay. All right, so I know what you're asking. Let me repeat it so everybody can hear it. All right, so I got this question on Piazza, and I've seen it myself. You're running the server, and an exception gets thrown in the server, such as that's how you return a status code that's not okay. Is you throw a forbidden status code. It doesn't kill the server, but it calls. If you're running the server in debug mode, it will enter a breakpoint in the server. And then you've got to go into the server, into Visual Studio, and resume executing from the point of the breakpoint. So that's a pain, right? So that's just a preference setting you can override. So next time it does it, you know, your code throws the exception, your Visual Studio enters a breakpoint, and there's a little box that shows up in the middle of the screen that's pointing at the line that threw the exception. And you're probably clicking on the X or something. But there's an option in that box if you click on the option, you can tell it to not do breakpoints on that type of exception anymore.
So it's exception settings.
Exception settings is a link you want to click on. So you don't click on exception settings up here at the top of Visual Studio. It's right in a box that shows up over your code. And you know, in the last few weeks, I've had to do that 3 or 4 times for different kinds of exceptions. So it's kind of weird. It's not like your Visual Studio is dying for an unhandled exception. It's just entering a breakpoint for some reason. Does that make sense? Okay. So there's several other questions I get a lot, which I'm trying to remember. But if anyone knows any sticking points I should talk about to everybody, I'd be happy to be reminded. Yeah.
I feel like this is maybe an easy one. I kind of look back in the lectures, but I had a hard time finding it. It seems like based on the code online, there are different ways that you need to send parameters to methods that are get and put and post.
Mm-hmm.
Can you just go over the different ways that you put arguments into those methods?
Okay. So yeah, I do get this question a lot. So let me open up another Visual Studio. Actually, I don't need to do that. I think I have the to-do list one open. So this is, so this is the controller. Let me make the font bigger. Okay, so let's just look at a few examples again. So here's an endpoint, post register, and it takes one parameter. And what ASP.NET does is it looks at the root and that header right there, and it figures out, you can give it help with annotations, but it'll figure out how it's going to actually receive the parameters when this is invoked via HTTP. And what it does is it sees, okay, this one parameter is an object, and this is a post request, and so it decides that that object will be passed in the body of the request. Now, how do you find out that that's what it decided to do? You run it and you look at the API that's generated. Okay? Now, it's possible, let's say instead of user info here, this was a string. So by default, what happens is, for that request, I think we saw this in class, it decides to put that string in the URL. But let's suppose we wanted it to come in the body. There's a problem with putting things into the URL. They're limited. You can't put every character in a URL, and you don't want to put sensitive things in the URL because they're not encrypted over secure connection. So if it's like a password, you certainly don't want it in the URL, you want it in the body. So what is the trick to telling the API, the ASP.NET, that you want the string to be passed in the body? Right, the annotation is from body. Okay, so there you're just giving a hint. I don't put this string in the URL, put it in the body. Okay? But of course that's not what we're dealing with here. We've got an object. Yep.
Question. One thing that I've noticed was from your server, from the past assignment, it says that it takes a string as a body. However, it can, like, depending on how someone implemented it by the client, they could either enter a object that has a string property in there, or they could either enter a string directly. However, I noticed, like, if you put like a string within the parameter, or you put from body as an object, if you put a string, and let's say if it was like an object, like as you have right there, which is from body as an annotation, it wouldn't accept it when I run it.
Yeah. I mean, if you say you want an object here, you know, there has to be an object, it has to be in the body, it has to have the right fields to it. And as far as I know, you don't have the option. If it says it wants a string in the body, you should put a string in the body, not an object containing a string field. Okay. Right? Now what if you did something like this? Suppose you wanted, for some reason, you wanted to pass in 2 user info objects to this post. How would they be sent to the server? What's that? Well, let's see. Objects are not going to be passed in a URL. The only thing that can be passed in a URL are simple strings and ints and things like that. So let's see what happens when we do this. I'm expecting there to be an error at some point, but I could be wrong. So it decided register user would take no parameters. So there's no way, it doesn't take any URL parameters, it doesn't take any body parameters. So you would notice that. I expected to see an error message. But basically, you're asking the impossible here. Okay, you can only have one one object as a parameter to post register. You can only have one thing in the body. You can't ask to put 2 things in the body. Okay, so that's one way. Let's go down to another one. Okay, here, this is the same sort of thing. It's a post. It takes an object, so by default, it's going to put the object in the body. And when you call it, you have to pass an object in the body. Here's a way to do it. I wanted this string to show up in the URL at that point, right there. So I want to be able to say to-do / mark completed / and then put an item ID in the URL. And so I just copy this parameter name up here in braces, and that just tells ASP.NET that I want it to get the value of item ID from the URL used to invoke the service. So that I give it some guidance. Same thing here. Item ID shows up there. And then down here, I get completed only and user ID. Both of these parameters come from up there. Now, if I wanted to, I could, well, this is a get. There's never a object in the request body of a get. So you couldn't do a from body here. Yeah?
Do you pass a dynamic object as the parameter, or just grab the properties you need?
Yeah, so you're talking about from the client side when you call the service?
On the server side, right where you have it right now.
Oh, declare this dynamic?
Yeah.
Declare something dynamic. We tried that before and it didn't work. Yeah, it wants to know what the actual properties are going to be. So putting a dynamic object as a parameter to one of these endpoint methods won't work. So for the purposes of your service, I I believe, at least when I did it, I had to use a from body annotation in a couple places. For example, when you register the user, it expects a nickname in the body of the request. But by default, it's going to try to put the string parameter in the URL. And so I had to override that with from body. And I had some questions like, I don't want to create a class, like, let's see, let's say there's an object that has two attributes in it. The question was something like, instead of passing in an object that has these two attributes, could I write my endpoint to take two separate parameters? And various questions like that, which boil down to, can I change the API so I can avoid declaring a class? What it boils down to. And what's the answer? Can you change the API? No. I mean, you can, but then your client won't work with it, and no one else's client will work with it, and most importantly, my unit test won't work with it, because it's expecting to invoke those methods in a certain way. Yeah.
So wait, every time we want to pass data from our client to our server, we have to basically serialize it and then pass it in through that parameter, but it has to be like one of those models.
Okay, you're asking about the client side.
Yeah. Well,
Okay.
my general question is just like, how does the client kind of like talk to the server?
Well, okay, you're asking how's the client talk to the server? Well, that's what you did last week. You wrote a client that talked to my server. So how did you do it?
I mean, I guess we just basically wrapped everything up in a dynamic object and then
And that was
passed it in
right. You passed it
response.
right. That's how you do it. So that's on the client side. On the server side, today we're concerned, or this week we were concerned with how do you set things up so that the interface that the client sees is what it's supposed to be. The API is followed. And that, to do that, you have to be a little bit careful about, you've got to, you got to get this right, because that's something the client sees. And if we go back up to here, the client expects to be, the API is going to tell the client that it needs to send in the body of the request, it needs to send an object that has a name and an email field in it. And so you've got to declare a class that has a name and an email field in it so that the API is generated correctly. Let me get his first.
Oh, I'm just, and so the body of the class is always the thing that's inside of the main braces. Is that what?
The body of
The body of the request.
the body of the request is from the client side. When you do a do post, you give the body along with the URL.
I guess I'm just wondering how to read the body API that you now.
So now the question is about the API itself.
Yeah.
Okay. Actually, let me go back to the generated API.
Well,
Right, so this is what you're doing with last week, right? This here, is this what you're asking about?
well, I guess it's probably better to use that than the one that you just pulled up. That's what I'm trying to do.
Right, this is the one, this API here is what's generated from your endpoint declarations, your root annotations, and the other annotations that you put in.
So reading that API is going to be much better for this.
Right. So as you're creating your service, you need to basically generate your API just by clicking on this thing, make sure it matches up with mine. Right? So like right here under post Boggle service /users, it better say Boggle server /users, not Boggle service /user. Right? The URL has to be the same. It better be a post, and the body parameter had better be a string, not an object containing a string property. Or it better not be a URI parameter. It needs to be the same. Yeah.
So I had a question. Is when we do, let's say for example, we do GET requests, and then we have it returned in object. What's going to do it? Like it's going to parse that, or it's going to serialize that object.
Mm-hmm.
Is there an easy way? So when it serializes the object, I know that we can use the things like data binding, or not data binding, but you can
Yeah.
choose which attributes to serialize. My question is there some using like a boolean? Is there some way to choose
Which-
conditionally which items get serialized and which don't get serialized?
There are ways to, okay, so the nice thing about writing the service this way is that you don't have to worry about doing the serialization of the data you send back. It's automatically serialized into either JSON or XML, depending on what the client wants. But you can, if you want, you can write your own serializer. You could write your own serializer method, and there's a way to have it be used. So you can customize it as much as you want. But as for what's available automatically, I'm not sure much beyond what I've shown you. Yeah?
So in user info that you just had pulled up under models,
Mm-hmm.
if you were to add, like, say 2 more attributes to that,
Right.
without passing them through the client, would it still then work on the server side for the methods on the server?
Okay, so you're saying, suppose I added one here. Well, if I add another public attribute, it's going to show up in the API first of all. And if the user doesn't provide it, I think I'm going to get a runtime error when I call the endpoint, because there's going to be an attribute missing when it tries to deserialize the object. So the only things, see, you need classes for a couple of reasons. You need to declare classes like this here in order to build the API. And then you need to have classes that hold your internal representation of your service. It's best if I guess I set a bad example because I use some of these classes in this to-do list for both purposes. One class for 2 purposes. Maybe you should think in terms of just having one set of classes that are just the models for the API and another set of classes that are there to represent the database. Because when you try to use the classes for both, you run into problems with having things that you don't want to be serialized suddenly being serialized. Yeah?
Is there a way to test our server using the client we built last week without I tried opening 2 Visual Studios, that doesn't work, so I'm not sure.
Okay. I'm glad you asked that question. So if you want to suppose you've got your client and it's on your PS9 branch, right? And now you've got your service and it's on the PS10 branch. And you want to play your client using you only run your client and use your service. Okay. So what I told you, and I didn't give enough details, is to create 2 Visual Studios and run your service in one and your client in the other. But what's the problem when you do that? They're on different branches. So when you check out, you've got a folder where when you check out a branch, that's where the stuff you check out goes in that folder, your working copy. So if you check out PS9, you've got PS9's code there. If you check out PS10, the PS9 code is thrown away and the PS10 code shows up. So if you're running Visual Studio here and you check out PS9, and you're running Visual Studio over here and you check out PS10, you've screwed up this Visual Studio over here, because it wants to look at PS9 code, but you've deleted all the PS9 code that was there, replaced it with PS10 code. It's not going to be happy. So what's the solution? Yeah?
You could make a separate branch and merge them both into it.
Yep, you could merge your PS9 and PS10 branches into one branch, and then have both the service and the client in the same branch. Or you could just create a new clone of your repo. You could have 2 separate clones, and then they have their own separate working directories. And you could have PS9 checked out in one, PS10 checked out in the other. Yeah?
I just used the executable created by PS9. Is that just as valid as other testing?
Oh, okay. So the other thing is, rather than running it using Visual Studio, you can just navigate to the exe file and double-click on it and run it that way. Is that what you're saying?
Yeah.
But you still have to have that folder. That folder has to exist somewhere. Mm-hmm. You can copy the executables and just run them. There are ways to do it. You just need to be aware not to get screwed up by the way. I think I told you when I first talked about Git, how students were coming up to me late in the semester shocked that when they changed branches, stuff was getting deleted and replaced with other stuff. That's a feature, not a bug. So you just got to be aware of it. If you sort of got this black box view of what Visual Studio, what Git does, eventually you run into trouble because you don't have a good model of what's happening. All right? Any other questions, or anyone think of any commonly asked thing on Piazza that I haven't covered here? Yeah.
So
So just to recap, for every post, get, or anything that needs an object from the body, it can only have one object in the parameter, right?
Right.
Okay.
Right. An endpoint, I want to say an endpoint can only have one of its parameters be an object, but that's not quite right because a string is technically an object. But, so except for strings,
So it can have a string and then an object.
yeah, you can have as many strings and ints as you want. They can show up in the URL somewhere, but only one real object in one of those endpoints, because that's all that can come in is one object in the body of the request. Okay, anything else? Okay, would some extra time help?
Yes.
Okay, so what I'm faced with is we got PS 10, 11, 12, and then we've got sort of this odd little half of a week at the end of the semester. So it's okay if we start sliding things a little bit, because we've got some slack at the end of the semester we can slide into. So I'll just extend the deadline by a day, so you can hand it in tomorrow or Saturday with a late day. PS 11 will come out as usual. I may just assign PS 11 with an extra day built in. Just it'd be a short week otherwise. Okay. Okay. Now, as has been the problem all semester, we're talking about databases at a time when you don't want to hear about databases. You're struggling with a server that doesn't use a database, but that's just no way around it. Unless I thought, what if our semester was like this? You come to school for a week, you have your classes, and then you get a week off when you do your assignments, right? And then there's another week of classes, another week of assignments. That would be kind of a interesting experiment to try sometime, but we're not in that world right now, so we got to do this. So this is what we were talking about last time. We've talked about databases. If you did the lab yesterday, you built a database that's the right thing to have next week. You got some idea how to write queries, and now what we're trying to get at is how to use a database from C# code as opposed to from a widget inside Visual Studio. And we went through most of these slides. I'm just going to fly through them until we get to where we left off. So first concept was a connection. To open a database, you have to connect to it. And anytime you open something that can be closed, just do it using a using. It'll be closed automatically when you exit the block. So that's how you connect to a database. And that connection can be to some database system running inside Visual Studio. It can be to something in the cloud. It's just determined by that connection string that you pass to it. You just tell it what database to talk to. Okay? Once you've opened a connection, you want to run a transaction. And a transaction is a unit of atomicity. The idea is anything you do inside the transaction, if the transaction is ultimately successful, then everything that was done will take effect in the database. On the other hand, if the transaction fails and is aborted, then there's no change to the database caused by that transaction. So it's all or nothing. That's what we want from transactions. Furthermore, the database takes care of concurrency control. So if you're doing a transaction and someone else is doing a transaction on the same table, the database system will be the referee. It'll try to do things so that it does things. It's guaranteed that it does things, so it looks like the transactions happened in some serial order. The price is occasionally a transaction can be canceled because of that, aborted. And you can tell if your transaction was aborted because you get an exception and you can just retry it. Although, honestly, I've really never had that problem with with the Boggle. You can just do something else with the unhandled exception in your client. Have the user try it again, basically. Okay, so that's a transaction. Then inside the transaction, you have one or more SQL commands. And a SQL command is either you're executing a non-query, like an update, an insert, a delete, or you're executing one of the above, but you want to get out, like you're doing an insert and you want to find out what key was auto-generated for you if it's that situation. Or you want to run a select, and pull data out. So those are 3 kinds of commands you see. That's an example of executing a non-query. So you put some update, you execute it, and you're told how many rows changed. You can use that to make sure nothing unexpected happened. If suppose you're doing an insert and you're expecting to get a value auto incremented for you, you run it this way, and you get back the thing that was auto generated for you, and you can do something with it. And to execute a reader, to execute just a select query, you do execute reader, and you get back a reader object, a SQL data reader that you can use to then extract the stuff that was the table that was sent back as a result of the query. And we talked about, don't paste input the user gives you into your queries by appending like that. Instead, you want to, we talked about that comic, but you want to have the code, have Visual Studio, have C# substitute for those @sign expressions. So we ask it to put task ID in place of @task ID. But when it does it, it sanitizes it. If it contains SQL code as opposed to a task ID, it gets backslashed and quoted and rendered inert before it gets put in there, so it can't come back to bite you. So think about it this way. Suppose you wrote, say, a Java program, and you gave the user could provide input, and when you got that input, you pasted it into your Java program and recompiled it and ran that. Right? What would happen if you solicited essentially code from the user that got pasted into your program, and then you recompiled the program and ran it? Yeah.
That malicious user basically just is like, oh, let's end this statement, and then let's just run a statement that says drop all rows.
Right. You wouldn't do that. You wouldn't trust someone that you don't know to give you stuff that you paste into your program. And you shouldn't do it when you're writing SQL either. Because what happens is you're building a query that is going to be compiled and executed for you on the server. So you better not let someone else write part of the query for you, which is the situation you're in if you just paste their code directly into your code. Okay, and this is what we didn't see. So before I do that, are there any questions I can answer about the stuff I just flew through? Yeah.
The add with value, is the parameters just a single add string and the replacement? So if you wanted to have multiple, you'd have to write them multiple times?
Right. So if there are multiple places you need to paste things, you would have multiple @signs and multiple of these these add with value things. Yeah. Did I start the recording? Remember? That's what. Yeah, I did. I've been doing pretty good lately, but. Okay, other questions? Yeah.
So we're going to be migrating our server to using a database, and we've got this user, and a natural key for these users to keep track of them is their user token.
Mm-hmm.
When designing, say, a user class, should we rely on the database to keep track of the token, or should we put the token in the user class? And so I'm just sort of wondering.
What's a user class?
Or it's more of should a class contain information about its key, or should that just be left?
Well, okay, so right now as you're creating this service for PS10, you're creating classes and you're using dictionaries to keep track of the data, the games and the users and so forth. That's all going away. So your static variables that hold all that stuff, gone. Everything's in the database. And so you'll be replacing your code that, your endpoints are going to be the same. The classes you declare to get the API right are going to be the same. But you're going to replace the implementation of the endpoints so that instead of manipulating some dictionaries, you're manipulating the database. So everything will be stored in the database, whether it's a user ID or not. It'll make more sense when I show you some actual code. Anything else? Okay, now, this is the last, no, I'm not there. Using readers. Okay, so to use a reader, we create the command, we execute it, we get a reader object. This read method here will read one line. Essentially, imagine you've got a table back as a result. And it has the columns that you asked for. So reader.read will return false if there are no more rows in the table, or it will advance to the next row and return true otherwise. So you say while reader.read, and then inside you can access like this. You just say reader, and then in braces, in square brackets, you put the name of the column whose value you want. So you can process a row at a time that you get back that way. Okay? So let's actually look at some code in action instead of just looking at slides. So this is the to-do list database version. And this method is post-register. So here we're just getting information about a user, name and email address, and I want to store them as a row in a user table. So I have a user table that keeps track of users. So let's see what happens. So right here, I'm opening a connection, and there's the connection string, to-do DB. So every time I want to open a connection, I need to use that connection string. Now, the question is, where did that connection string come from? So if we come up here, you'll see I declared a single static variable called to-do-db. It's just a string. So I declared the connection string as a static variable. And then down here, I go off to the configuration manager and ask for the connection string for this database. So the connection string is actually stored somewhere else in the project. Why do I do it that way? Why don't I just put the connection string right here in the code? Yeah?
So you don't mess with it?
Yeah, I mean, he said so I don't mess with it, but also so I can change it easily. I just have to go to one place to change it. So what I did was, we'll go into the to-do list server here. There is a file called web.config that's part of the project. Here it is. And right up at the top, it's just an XML file. I put this in. And you'll need to do that too. I put in a connection string. And here's what the connection string looks like, and yours should look something like this too. It says the connection string is data source equals local db slash mssql local db semicolon blah blah blah. Make sure that's how it ends. Data directory in vertical bars slash the name of your database MDF file. That will make it portable. Don't put an absolute address there, or it will work on your computer and not on anyone else's. Yeah?
And this will be auto-generated. So
the web.config is auto-generated when you build the project. Then you'll have to edit it to add. All I did was I took the existing web.config and just at the top I added connection strings. I added these 3 lines. So you'll need to add those 3 lines. And the only thing you'll have to change is your database won't be called to-do list.mdf. It'll be called whatever you call it.
So
Yeah.
the actual connection string is generated inside that other program, and you just copy it inside that other file.
No, the connection string isn't generated. I just looked up the documentation and find out what's the connection string for a local database look like. And that's what it looks like. All you have to do is copy my 3 lines and be sure you put the name of your database there instead of this one. Yeah?
All we're doing here is just giving us a route to the database.
Yeah. What this is doing, so that the data directory part is what makes it portable. It's a relative address of your app data folder. So this works only if your database is in your app data folder. Yeah. And then it says inside that folder how to find the MDF file. Now, if you were using a database on the cloud, the connection string would look very different. It would look more like a URL, https:// blah, 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 and it would contain within it a username and a password your credentials to connect to that database. But this local database doesn't have any security built into it. It's just meant for development. Okay? So be sure you get that connection string right. And then the code I was showing you here is just, you can copy this too, that's just going out to that configuration file and finding the thing that's called a to-do list DB. I guess that's something else you'd have to change, is the name of the key. You may want to call it Boggle DB or something. And gets the connection string into the program. And then we store the connection string in that static variable so that we can use it everywhere. So anyway, there's a connection string. Here I open the connection to the database by doing that and then actually saying open it. It's 2 steps. Then, like I showed you, I begin a transaction. And you'll notice there's lots of comments. You don't have to read them right now, but that's so you can look at them later. Okay, so I begin a transaction, and then the command I want to use is this one. I want to say insert into the users table a user ID, a name, and an email address. And the values to use for those are @user ID, @nickname, and @email. So those are, you can name these whatever you want, but I just gave them the same name as the column. And so we do the insert, and before we can do it, we have to actually paste in values for those @ expressions. So I generate a globally unique ID, and I use it. I replace that @user ID with the globally unique ID. I replace @nickname with whatever name the user gave me in the incoming parameter. I replace @email with user.email. Now I've got my query is built. I execute it and make sure that I get 1 back. I should add 1 row to the table. If it tells me it didn't add any rows, something went wrong, and I throw an exception. If nothing goes wrong, I commit the transaction and return the user ID, because that's what this method is supposed to do. Now, suppose you did everything, but you didn't put that in. Suppose you did not commit the transaction. Did everything else right. What would happen when you use the service? Yeah?
I think, does it work like Git, where you can't do anything with uncommitted work?
Okay. Yeah, so he's saying you can't do anything with uncommitted work. Actually, it's different than that. What happens when a transaction ends and you didn't say commit? Meaning, right, it's as if the transaction never happened. So you could go in here and start deleting all the tables in your application. But as long as you don't say commit, actually I wish I hadn't said that. Don't try that. But in principle, it shouldn't take effect until you say commit. Okay? And you can also do trans.rollback, and that says cancel the transaction. I don't bother, and I just, like when that exception gets thrown, the commit will never be executed, and that automatically exits the transaction and calls the rollback anyway. Yeah.
So add with value, it's surprising to me that you would do that. Like add with value, that sounds like you're adding it every time. And I'm surprised that you would call it 3 times instead of.
Well, there are three placeholders to deal with, right? So I've got 3 placeholders up here: @user ID, @nickname, and @email.
You're just declaring a variable, basically.
Yeah. So I'm saying this says go find everywhere @user ID is and sanitize this and put it in its place. Replace all the @nicknames with a sanitized version of this, and so on. So any data you want to take from the user, I probably didn't have to sanitize the globally unique ID because that was generated by the program. I'm just in the habit of doing this. Anything I want to paste in, I paste in that way. Yeah?
So what is execute non-query returning?
Execute non-query returns the number of rows that were changed in the table. And since we're just inserting a single row, we expect the answer to be 1. That's just a sanity check. So if we get back that it affected 0 rows, that means the insert didn't really happen.
Or for some reason it executed more than 1 row?
If you get more than 1, that'd be really weird. But yeah. So what you find when you work with a relational database like this is you end up writing a lot of boilerplate code. And by that I mean, let's look at what I had to do. I had to open the connection, began the transaction. This line right here is actually the query I want to execute. So that's specific to the problem. You know, this bit of code, you know, is doing something. But you end up writing a lot of the code over and over again and end up copying and pasting. So there are other ways to use databases. I believe that when you first use a database, it's good to just use it sort of at the lowest level, relational database, writing SQL statements against it. But people long ago have gotten fed up with this sort of thing. What you'll find is when you use a database, a relational database, the data is in tables, but your program wants the data to be in objects. And so you'll find yourself taking objects and using the data in the objects to populate a query to store in a table, and then getting information out of the table and turning it back into objects so you can work with it that way. So there are systems called, you know, one thing they're called are object relational maps, which essentially let you say, okay, I want this data, and you describe the data in terms of classes, C# classes, let's say, and then you say, make a database for this, and the database is basically generated for you. The system looks at the data you have and figures out what tables are needed. And you just say, later, when you're using the database, you'll say something like, save these objects to the database. And it figures out the query to use to send it. And you say, get these objects out of the database. And the objects come out. And that's sort of all done automatically. It makes it a lot more streamlined process. But I have sort of a philosophical objection to, before you start using stuff that does magic for you, it's good to know what's going on behind the scenes. So that's why I sort of insist that we work at that we work right at the relational database level, so you can see what when you use an object relational map, you'll appreciate what's being done for you. Okay? So what would you have to do as prep work before you wrote your first database command here? What did I have to figure out before I started opening connections and starting transactions? What is sort of yeah?
Figuring out like which table you're inserting into.
Right. Basically, I had to figure out this query. I had to figure out what query I wanted to do. And so it's good to test this query out, make sure that you know how to insert a row into the table, and then just copy it. Typically, you would write a query like that. You would have to put instead of putting these @ signs in it, you would put some real data. Test it out, make sure it works, copy it out, and then replace the real data with placeholders. So you experiment like I showed you last time, then just paste it in. Okay? Okay, I got some more to show you, other examples of the other endpoints. Let's take a break and we'll look at some of those. Okay, so I was talking to students at the break. So one thing I just want to emphasize, that's a command, and what you're doing in this part of the code doesn't involve the database server at all. You're just building the command, which is just a string. So all that code is devoted to building the command, and then once it's created, once all the placeholders have been replaced with values, that's where it's actually executed. It's sent to the database server and executed there. So if we're using something on the cloud, this is where that execute non-query is going to go out over the internet and send the query over to the server, and the server will send some stuff back. That all happens behind the scenes. Okay? Another thing I pointed out was this language, SQL, is like 40 years old. You know, it's been around forever. And so, you know, it looks kind of clunky, very verbose. You know, it's from the 80s at least, or most. It could be from the 70s, I don't remember. So, yeah, it's kind of an old-fashioned language, but you know, you can write Python code and have SQL in it, C# SQL in it, Java SQL in it. That's what it looks like. All right, let's look at another example. This is where we add an item to our database. So it's going to look pretty much the same. I do a little sanity checking first before I open a connection. Do as much as you can before you open the connection. And so I open the data connection using the same connection string. I start a transaction. I create a command, which is just, this is a select. So our goal is we're trying to insert this item into the items table. But one thing the item contains is a user ID. So the item contains a user ID and a description. So why am I doing a select command at this point? Why am I building let me show you what I'm building. Right at the top there, right here. Why am I building this query? Yeah.
Make sure the item doesn't duplicate a user to add a description, and you just add it to.
Well, okay, the user ID is not an ID for the item. It's a unique key for the user. But you're on the right track. Why would I be looking up the user ID if what I want to do is add something to a table? Yep.
I think basically says, are you just trying to check that person actually exists?
Right, trying to make sure that person actually exists. So what I do is I say select user ID from users where user ID equals @user. So I build the query, I substitute in the actual user ID right there. And then I execute the query, and that's a select, so I get back an SQL data reader. And all I care about, I don't care what data comes back. I just want to make sure there's at least one row, that it found that user ID in the table. So I say if the reader does not have rows, I close the reader, I commit the transaction, although there was no reason, nothing changed, and I throw an exception that says forbidden. I don't know that user. Otherwise, I go on. So first, I make sure the user ID exists in the database. Then it's like before. I build I call the insert method. I give it the user ID I just verified, a description, and whether or not the task is to be marked as completed. And for the values, I'm going to substitute in later. What's this for? We didn't see that in the last query. That is just right. That is so that we can. It will tell us after it does the insert what item ID it generated for us. So the item ID is not being provided. We're depending on the database to auto-generate it. So we're asking it to tell us what was the item ID. So we get that thing. We substitute in the actual values of the placeholders, and then we execute the command with execute scalar, and we're expecting to get a string back, which is the item ID. So we do command.execute scalar, and then we say toString to capture the auto-generated thing. We get the item ID, we commit the transaction, then we return them item ID because that's what the endpoint does. Yeah? Oh, without a question. Yeah?
Previously, when you're checking on the rows, when it exits without committing, you said it automatically does a rollback.
Yeah.
Would writing in, like, saying, like, writing in the rollback and then exiting, does it do two, or does it?
No, it only gets rolled back once. So if you explicitly roll it back. But, I mean, the thing here, we got this, if this is executed, it means we got back no day when we did the query. So a select doesn't change the table. So I didn't really have to commit here. It doesn't matter if I commit or roll back. The table hasn't changed. But I guess I just put commit there out of habit. Yeah?
Sorry, where it says execute scalar, that's where we're actually doing the insert then.
Yeah, so it's the, let me see, that's the select. Yeah, right here. Execute scalar is where the database gets involved. And that just runs the command on the database, but it returns something. The execute with scalar gets back the auto-generated key that we need. That's sort of seems like every different SQL database has a different way of getting auto-generated things back. And this is how you do it in T-SQL. Now, it's always a challenge to try to do more with less. So I wrote two queries. I wrote an insert, a command really, to change the table. I also wrote a select to verify the user ID. So that was two. It's possible to do it all with one query, with one statement. So how could we, can you think of why it's possible to, as we're doing the insertion, finding out whether or not that user ID existed in the original table? That's sort of a kind of advanced question, but I'll put it to you.
Do you locally store it?
No, I don't have anything locally stored. Okay. I'll answer my own question. I don't like to do that, but I'll do it in this case. Well, maybe I won't.
You're just talking about updating it? Like
No.
select where
Now, what I propose to do is to get rid of the select completely and do everything down here in this insert. So, yeah.
Could you, like, make two different threads and have one check?
No, I'm not talking about multi-threading either. Yeah?
Can SQL have conditional statements to execute parts of it?
Well, he's proposing maybe a conditional statement, but no, in fact, I propose to use exactly the same insert statement. Yeah?
is there a from keyword?
There may be, I mean, I think it may exist, but it's optional in this case. Insert into items. Yeah, I propose to use the exact same insert. Yeah?
Well, we have that index number that's supposed to automatically increment
Yeah.
in the execute scalar. If that number doesn't change from what it was before.
Okay. That's getting closer. So let me suggest this. When I design the tables, so I have a table with users and a table with items. There's a user ID column in the items table. There's a foreign key constraint on that user ID. What does that foreign key constraint say? Yeah.
It creates an obligation that every user ID that shows up in the items list must match the user ID
Right.
that showed up in the user list.
Right, so I added a foreign key constraint that says if any user ID that appears in the items table has to also exist in the users table. So what I could have done is skip the check, just go do this insertion, and what would happen if that user ID didn't exist? It would violate that constraint that says that that you can't do that. And at that point, I'm not sure what would happen. We'd either get an exception back that says you violated a foreign key constraint, and we would need to catch that exception and tell the user that something went wrong. Or maybe that the attempt to do the insert would fail and we could detect it another way. So there's some way, I'm sure, to detect that a foreign key constraint was violated. So instead of checking the user ID exists, we could have just gone ahead and say, do the insert, and relied on the database to detect that constraint was violated. When we find that out, we take action. And I suspect when I wrote this code, I didn't want to think that hard, so I just wrote two things. And that's often the case. I'm up against a limitation in my knowledge of SQL, so I just do what seems simple instead of what might be optimal. So you got your choice. Let's look at another one. This one marks an existing item as completed. Right? So we're getting an item ID, and we're going to mark it as completed. So we got to update the row that item ID occurs on in the database. So again, I open a connection, start a transaction, create a command, and let's see what the command is. It's an update. It says update the items table, set the completed field to true on every row where the item ID equals the ID the user gave us. Then we paste in true and item number. Now, why didn't I just put this true right here? Why am I mean, clearly that doesn't need to be sanitized, because I wrote that myself. Yeah?
I think it's a good habit.
It's a good habit. The other thing is, I'm not exactly sure if I should use true or 1. Right? I'm up against a limitation of knowledge of how this version of SQL works. So I just do it that way and let it figure out what to put in there in place of that @ true.
I don't think it has a, if it's 1. I don't think it has, at least SQL Server doesn't have a true.
Yeah, so it probably is 1. Anyway, so I create that query. Now, we're about to execute the query. And what we get back is a number of rows that were modified. So what does it mean if no rows were modified? What if we tell it, update the row that has item number 7 on it to be completed? Yeah.
The user ID didn't exist?
Not the user ID didn't exist. There's no user ID. The item ID didn't exist. So we were asked to mark item 7 finished. There is no item 7 in the table. And so we find out about it because we're told how many rows are modified. If it tells us 0 rows were modified, we know that user ID didn't exist, that item ID didn't exist, so we send back the forbidden result. We're saying, we just give that HTTP status back. Otherwise, we're good. Right? So here I didn't go and check to see if the item ID existed before I tried to update it. I just used a return value for that purpose. This reminds me of another commonly asked question. I could have answered at the beginning of class. If you want to, there are lots of error codes, lots of status codes you can send back, like forbidden. And those are sort of failure codes. So if you want to send a failure code back, the way you do it is you just throw an HTTP response exception, and that sort of cancels the endpoint and sends back the response code you tell it to send back. Okay? The question I get over and over again is, what if there are lots of success codes as well. There's 200, which is okay. There's 204, which is no content. There's another one, which is created, and so on. What if I want to send one of those back? Okay? So if you want to send, the news is, if your endpoint is void, if your endpoint method is void, the success code will automatically be no content, because nothing is being sent back. If your endpoint method is not void, the default success is okay. And I created the API, so those are the only 2 options. So you don't have to ever send back created. And you don't have to send back okay when the default is no method, no content. In fact, I had to change the API to make that the case this year, because it looked to me like, and I think some students agree with me, you have to stand on your head to send back anything other than okay or no content. So fortunately, it's not necessary. Okay? Sometimes we want to delete a given item from the table, from our database table. So let's see how I do that. I put this query here, delete from items where item ID equals item ID. I plug in the item ID, I execute it, and either I get 0 back, which means nothing was deleted, which means the item ID was bad, or I don't, in which case I succeeded. So it all starts to look the same. Finally, the last example here is the get all items. So that involves a select. So we're given whether or not we're interested in completed items or all items, and we're given either a user ID or the string all, which governs which items we actually see. And let's see what I have to do. I have one bit of code here that if user ID is not all, I build one query. Otherwise, I build a different query. So anyway, bottom line is I'm building like select user ID from users where user ID equals at user ID. All right, so I create a select to give me back. Okay, that's just validating the user ID. So I validate the user ID there. Then I create the query to actually do, to do the selection. I select description, completed, and item ID from the items and users table, where items.userid equals user.userid. So I'm doing a join on the two tables. I'm trying to find all the items that belong to that user. And then I may add and completed equals true. That's how you do true at the end of the query if necessary. And I may say I'm only interested in certain user IDs, depending on what parameters the user gave us. But anyway, I build the right query I want to do, and then I execute it. And what I want to look at is how I consume it. So what's going to come back when I execute this query? Select description, completed item ID from the join of these two tables. Conceptually, what do we get back from the database server? Database contains a bunch of tables. What do we get back?
Another table.
Right. Essentially, we're asking it to give us back a table. What are the columns in the table?
Description, completed, item ID.
Yep. Description, completed, item ID. So that's what we're asking for. So we're going to get back a table that has those 3 columns and how many rows?
As many as there are completed items.
It just depends, as many as there are, as many as meet our criteria. So now, we're getting back a table with a bunch of rows in it. What do we want to get back to make this endpoint work? Let's see, the endpoint is supposed to return an I list of to-do items. So it's supposed to return a list of to-do items to be serialized, and to-do items have a user ID field, a description field, a completed field, and an item ID field. Okay? So what are we going to have to do? Let me get back my window. What the heck happened to it? Okay? What are we going to have to do with this table to turn it into a list of to-do item objects? Yep.
Check for completed.
Do what?
Check if they're completed because we have to complete.
Okay, but we've got it set up so we're going to get exactly the data we want. So we're going to have, like, let's say we get 20 rows back of items that are completed or not, depending on what the user said. So we've got the exact table, we got the exact data we want to send back to the user. How do we package it up to send it back? We can't return the table. Yeah?
We basically have to, it's sort of like serialization or deserialization of the table into a to-do list item.
Right, we have to convert that table into a list of to-do list items. And that's what I was saying. You often find yourself using a relational database turning table data into objects and back. It's kind of annoying after a while. And that's when you abandon the relational model and try to use an object-oriented database. So let me show you how that works. Okay, here's where we execute the query. So what I did was I created an empty list of to-do items. I execute the query and I get back this reader that's going to let me go one row at a time through the data. So I say, while there are some rows, for each row, I create a new to-do item right here. So I create a new to-do item whose description attribute is whatever was sent back by the database server in the description column, and completed is whatever was sent back in the completed column, and item ID is whatever was sent back in the item ID column. So I just take the data out of the row, build an object from it, and add it to the list I'm building. So I just suck that table dry, populate a list. Yeah?
When we say a reader, and then we say we're given it the brackets in the description, is the object that returns back, because I see we're passing it to a string, is that return a dynamic there? Or
I think this is written to return an object.
just object, okay.
And you have to know what type of object you're expecting. You know that this field contains strings. That field contains booleans. Other fields contain ints. So you just cast them or call the toString method on it as appropriate.
Is that similar to like in PS9 when we deserialized and knew what we were getting? So we
It's similar, except there's no use of dynamic objects here. Yeah?
Would there be a reason we wouldn't want to just create a constructor for to-do items?
Oh, you could. It's just that, yeah. You could do that. You could create a constructor and just call it, or you could just initialize the attributes this way. And then when you're all done, you commit the transaction and then return that list. And then it gets, so you see what's happening is you do a query of the database, you get some of the rows of the table back, which you then turn into a C# object. And then what happens to that? It gets serialized and sent back to the client, who deserializes it into some object, whatever language is being used on the other side. It doesn't have to be C#, and does something with it. So there's a lot of translating going on. And the more this can be automated, the easier it is. So this, this to-do list example is pretty simple, but it shows you sort of one of each kind of thing you need to do. How do you get auto incremented stuff out? How do you build the queries? How do you consume a result table? So that's definitely the place to look when you have questions next week. Now, in the time that's remaining, this is what I want to do. So here is that database that you built yesterday, except it's not going to magnify like I want it to. Let's look at it. So you have a users table. Users table contains user token and a nickname. Right? So that makes sense. Each user is going to have a user token and a nickname. And then it has a table called games. And a game has a game ID, the user token for player 1, the user token for player 2, the string that represents the board, the time limit of the game, and the time at which the game started. Okay? That's useful. And then we've got words where there's an ID, for just to make each row unique. It has a word that was played, the ID of the game it was played in, the number, the ID of the player who played it, and the score that the word got. Now, one thing you'll notice is that this table is not structured like your dictionaries. Okay? You've got a single table that contains every word played by any player in any game since the database started. They're not like, it's not like you have one table for one game and another table for another game. That's how you're used to thinking about things. You probably, in your representation right now this week, you probably have an object that represents a game, and it contains all the information about that game. Then you have a separate object to represent another game. This is just one table that contains every word, every game, every player since the beginning of time. And it can be confusing when you try to figure out how to extract information. So let's take a use case. Suppose you wanted to know all the words played by a particular user in a particular game. How would you get that information out? what query would you write? So in fact, let's try writing that. So I'm going to come here and create a new query. Okay? So here's the words table. If I give you a user ID and I give you a game ID, how would you get the words played by a user in a game? Okay, so we're going to select from words. And let's say we just want to know the words. We didn't care about the score or anything else. Just to know the individual words that are played. So what would I select from the words table? I would select word. Hope I get the syntax right. Am I doing it right?
Select words from word?
Yeah, word.
Okay. Is it select?
Word from.
Select word from words. Okay. Yeah, see, I am not the world's expert on this. Select word from words where what?
Token or player is.
So let's say we're interested in player one, where player one equals something and game ID equals something. Okay? So if we knew an actual game ID and a player ID, we could substitute that in and get the information out. So when you first start to think about the best use of your time when you're starting on this is to be thinking about these tables. For each of your endpoints, think about what methods you're going to have to write, what queries you're going to have to write to pull those stuff out. Okay, so like at the end of the game, when you've got to generate a status that shows all the games, all the scores and words, that's a select like we just saw. What's another thing you'll have to do to get, what other kind of data we have to get out for an endpoint? Okay, yeah, you certainly got to do a query for both players. You have to do one query to get player one's words, another one for player two's words. Okay, what about when someone plays a word? Suppose you get your play word endpoint. What does it take as parameters? What information does play word get? You know it better than me at this point. Yeah?
The user ID and the word they play, and the game.
Okay, so you get a user ID, game ID, word played. Okay? What kind of command will you have to do to record that? What table will be affected? Yep, you'll have to add to words. If a word is played, you'll have to add a new row to words, so you have to use an insert. And the word that you put in is going to be the word that came in the request. The game ID will be the ID that came in the request. The player will be the player ID that came in the request. And the score will be whatever that word was worth. Now, what about the user ID could be bad, right? The game ID could be bad. How do you cope with that? There may be you put in some foreign key constraints that could help with that. So in particular, you know that this game ID has to exist in the games table. So there's a foreign key constraint there. And also this player ID has to exist in the users table.
Well, shouldn't that player also exist in the game?
But you've also got to make sure that the player exists in the game. So you may have to do a query to make sure that the player is eligible, is one of the players in the game before you add the word to the table. So you can't reserve, you're not going to be bailed out by the foreign key constraint every time. So anyway, before you worry about writing code at all, what I would suggest you do is you sit down like I'm doing right here. You've got your 3 tables that you did in the lab. Put some sample data in. You can do it directly from this interface. You don't have to write inserts to do it. And then think about your endpoints and figure out what SQL code it's going to take to put data in and get data out. And try writing it and experimenting with it before you start writing any C# code. Think about it, and Tuesday we'll do more of this with some actual data, see how it works out.